And let's go over the practice quiz. Welcome to AP Stats. And problem one on the practice quiz, administrators at Texas A&M were interested in estimating the percentage of students at the school who are the first in their family to attend college. Now remember that in statistics, we're trying to uncover the truth about one of two parameters in reality. What are the two parameters that statisticians care about? Who can review that for me? At least one of them. Of the two parameters, what's one of them that you know? Mean. Sometimes we want to try to find the true mean of something in reality. What's the other parameter? Now, standard deviation is a parameter, but it's very unusual that we design a survey to find the true standard deviation. But I'm glad to know that you realize that standard deviation is a parameter. But the big two are mean and, Justin, I think you said it, proportion. And in this case, we're trying to uncover the true proportion. What proportion? They use the word percentage here, but it's the same idea. What proportion of students at the school who are first in their family to attend college? So instead of taking a census and asking everyone, they're going to do something less expensive, and that is conduct a survey. So the administrators went to each room in one of the dorms and surveyed all the students in the dorm. Okay, so in these problems, problems 1 through 5 are graded either E or I. There's no P's on these, so give yourself either an E for essentially correct or an I for incorrect. Not that this is going in the grade book, but just to show you how it's graded. What's the population of interest? Essentially, what we're trying to do here is figure out what is the circle that represents the population, because reviewing vocabulary, in a survey you have the population of interest, which is the outer circle, the sampling frame from which we create our sample, and then the innermost circle is the sample itself. The population of interest is, and notice how specific the wording has to be. It's the 46,000 member Texas A&M University student body. It's not 46,000 students. It's not all students, because all students could be students at other colleges. You have to specify where is the population whose parameter we're trying to uncover. It's the 46,000 students at Texas A&M University. Notice how specific that has to be. Any questions on how to grade yourself on that? Yes,
did you say the current Texas A&M student body?
Yeah, if you said that, that would get an E. That's essentially correct. Okay. What is the population parameter of interest? Okay, once you see that word parameter, you know it's either going to be a mean or a proportion. So you read the original problem, you see, oh yeah, this is a proportion. So population parameter of interest is the percentage, or ideally you would say the proportion, either one is full credit, the proportion of students at the student who are the first in their family to attend college. Any questions on these first two? Again, great practice for how specific the wording has to be on tomorrow's quiz. What's the sampling frame? So instead of the green circle, we're now moving into the purple circle, the sampling frame. And notice what they did. They said, well, instead of looking at a list of all the students, they decided they went to each room in one of the dorms and surveyed all the students in the dorm. I wonder how they selected that dorm. I wonder if they picked it at random, or whether they say, oh, that's the dorm closest to the administration building. If it's the dorm closest to the administration building, then what kind of sample would that be? A lazy convenience sample. What if they picked that dorm randomly? Then what type of sampling strategy?
Simple random sample.
If they pick the dorm randomly and then survey everyone in the dorm, that's a cluster sample. That's a cluster sample. Okay, in a simple random sample, every subset of size n is equally likely to be chosen. In this case, there's a subset of the 46,000 members that could not possibly be chosen because there are students who perhaps are not in that dorm. Yes?
Why is it not simple random sample?
Okay, the definition of a simple random sample is that every subset of size n, and did they give us a sample size? Suppose they ended up sampling, 302, no, let me make it 302 people. Well, if it's a simple random sample, then when you consider these 46,000 students, every subset of size 302 is equally likely to be chosen. Even 302 students who are in a different dorm. And since that's impossible, since that has probability of 0 because of the sampling strategy they used, it cannot by definition be an SRS, a simple random sample.
So because they chose one dorm, it's a
Because they just picked one dorm, then it's no longer an SRS. Whether they picked it randomly or not, we don't have an SRS. All right, so great questions here. And sampling frame, okay. They picked that dorm. Not everyone's gonna be home, or not everyone's gonna answer the door. These days, who does answer the door? I'm not answering the door. Hide in the closet. That's kind of funny. The sample is the students in each room of the selected dorm that were actually sampled. So the sample is basically the students who answered the door and responded to the questions. And finally, the sampling method, it's a convenience sample, or see, it says, the rubric says, if you said a cluster, that's okay. So they accepted, since it's not specified whether or not they randomly select that dorm or whether they just conveniently picked it, you can get other one. Any questions on 1 through 5 on the practice quiz? Thomas,
What's number 4 saying?
what's number 4? Okay, what is the sample? They want you to describe the inner circle. We got the population, 46,000 students, the sampling frame, which is the dorm, and then the actual sample is the people in the dorm who actually responded to the knock on the door and answered the questions.
Gotcha.
So, great review of vocabulary. Notice very few numbers, even though it's a math class. No, it is a math class, but it's really a writing class. We're in a technical writing course right now. Oh, by the way, suggest a reason why the results might not be generalized to the population of interest. Or in other words, why might this sample not be representative of the population? Here's one way to answer it. The results might not be generalized to the population because the sampling method is exposed to several forms of bias. And, I mean, all you have to do is note one of the reasons. It says a reason. There may be undercoverage bias for Texas A&M University who do not live in dorms. So that's undercoverage due to poor sampling frame. If you mentioned undercoverage due to poor sampling frame, that's a great answer. Further, there may be a convenience bias. Sampling, for example, the dorm primarily houses athletes and non-athletes are undercovered. So, yeah, I think that undercoverage due to poor sampling frame is going to be your best answer there. So let's call for questions on page 1 of the practice quiz. So let's go over to page 2 as soon as you're ready. Then, all right, page 2. Okay. In conducting the survey, the administrators asked the following, quote, "Are you the first member of your family to seek higher education?" Unquote. 7, explain how the wording of the question might lead to an incorrect estimate of the parameter. There's 2 types of bias, 2 umbrella categories of bias. One umbrella is response bias, that's the fault of the survey engineer. And a big place where survey engineers mess up is in the wording of the questions. Yeah.
Can I get an extra, please?
Sure. And the other type of bias is non-response bias, and that's the fault of the person taking the survey. So, it's one of the hardest part of designing surveys is avoiding response bias when you devise the wording of the questions. Are you the first member of your family? Okay, so How might that lead to an incorrect estimate? Well, the wording of the question is ambiguous. Does family member refer to nuclear family? Does it mean the extended family? So yeah, first member of your family. If you're gonna design a survey, you gotta really clear in your communication, what do you mean by the words that you're using? So, and what does higher education mean? Does that mean four-year college? Would community college and two-year college qualify as higher education? The ambiguous wording will lead students to answer differently from how the administration intends. So, ambiguous wording is the basic content that you want to put into your explanation. Any questions on problem 7? Yeah, that can lead to response bias. In case you're wondering, what type of bias is it? Well, I mean, we don't have a specific term for something like ambiguity bias. So if you don't have a special category for the type of bias, just put it all under the response bias umbrella. All right, number 8. For each scenario, identify the kind of sampling strategy that was used by the administrators. So, here we go. Select several dormitories at random and contact everyone living in the selected dorms. What type of sampling strategy is that, friends? Cluster is correct. B, use a computer-based list of registered students. Contact 200 freshmen, 200 sophomores, 200 juniors, 200 seniors at random from each class list. Raise your hand if you're reasonably sure you know what sampling strategy that one is, Andrew.
Multi-stage?
Multi-stage is, I can kind of see why you said multi-stage, there are several steps to the process. What are you thinking on this one, Kennedy?
Stratified sample?
Yeah, stratified sampling is correct because the 4 classes are the 4 strata. And, you know, is it proportionate stratified sampling? Well, if each class is the same size, yeah, but now we actually found out what N is 800. So they wanted to say 25% from each class. It's a stratified sampling, just textbook stratified sampling. Part C, using the computer-based alphabetical list of registered students, select one of the first 25 on the list by random, and then contact a student whose name is 50 names later, and then every 50 names beyond that. What is the name of the sampling strategy that's being described in this one? Raise your hand if you're reasonably sure you know which one that is. If you want to look at your list of sampling strategies to kind of sort that out, you can, but all right, Peter?
Systematic.
It is systematic. I mean, there was a smidgen of randomization in this, but essentially it was systematic. They just randomly decided where they're going to start, and then they went systematically from there. Systematic sample, and then number 9, instead of surveying a dorm, this design is proposed. Let's randomly select 250 students and mail the questionnaire to their home. Identify a problem with the design and explain how it would affect the estimate. Well, that could lead to a non-response bias. It's not the fault of the survey engineer, but you get a lot of people not respond. For one reason or another, students may not want to disclose if they're the first in their family to attend college and not mail the survey back. This would make the estimate to be lower than the actual proportion of students at school who are the first in their family to attend college. So, anyway, just want to make sure you had exposure to a practice quiz there. Nick, go ahead.
I have a question. So the question is asked, identify the problem with the design. Since the non-response bias is not the fault of the survey engineer.
Yeah, well, a problem. So, Louis is here. Louis. We're just going to rubric to practice quiz. So if you have a practice quiz, just take it out. All right, so Nick, if I'm understanding your problem correctly, it sounds like you're wondering if a survey engineer designs a survey that's subject to non-response bias, isn't that essentially a mistake made by the survey engineer? Yeah. Well, it's a good question. The answer is that, I mean, it might be a mistake, but we still categorize it as response bias. Excuse me, as a non-response bias. So, yeah, it's a thoughtful point that you're making. But when the problem is manifest by a lot of people not responding, to the point that if the sample's not representative of the population, we just call it non-response bias.
I know, but the question is asking, what is the problem with the design?
Yeah.
So it's asking what is the designer's problem, am I right?
Yeah, you know what, that's, what you pointed out is that even non-response bias is a response bias. You are correct, there is an element of fault that the survey engineer has when they design a survey that's subject to non-response bias. So I've never really thought of it like that before, but that's because of your really careful reading of the problem that you've helped me learn something today. So thank you, Nick. Thanks for putting that out. That's awesome. Further questions or comments? Frodo.
Following for number 8A.
8A? All right, let's take a look at 8A. Yeah, go ahead.
If I add another sentence that after randomly select one door, then I randomly select one this student living this room, for 2 or 3 students on each room. So it's going to be the a multi-stage or still cluster.
Now, if I'm understanding you correctly, you're asking a question about an alternate wording of number 8A, is that it? Or perhaps I just didn't hear your question fully.
So first school randomly select several rooms or rooms from school. Then it's later after that I randomly select these students again. So it's equally considered as a cluster or multi-stage.
Okay, so, and you are referring to problem 8A, is that correct? Okay, so you said that, and again, I just want to make sure I understand your question. You said if they select several dormitories at random, and then you mentioned something about how they run into some of the students again?
Right.
So like they're at one dormitory asking their questions, and then they go to the next dormitory, and then some people from the first dormitory had kind of migrated over, or what?
So we have several clusters already. That means like
Several clusters have already been selected,
right,
okay.
that's the law. And we have a group of students, it's like this, and they randomly select for each student.
Then they randomly what?
Select a new group, like a smaller group for each student. It's equally considered as a multi-stage.
Okay, so, and if you would please, Teresa and Zoe, let's just focus in on Frodo's question, because other people might have this question also. I want to give people, and especially Frodo, a chance to concentrate on this. So it sounds like you're describing a sampling strategy in which several dormitories are selected at random, and then, before we start asking questions, we then randomly select a subgroup of people from each dormitory?
For this dormitory has been selected already.
Yeah, then the answer to your question is yes, that's multi-stage. That's a multi-stage sampling strategy. Yeah. Further questions on the quiz?
So for like entry, like the bias, we just have to say like what type bias it is. We have
On which one are you referring to?
like, well, let's see like number 6.
Okay.
For this one, it has like a form of bias. So like, so do we need to because okay, so I said that like the sample may have bias because like they specifically like pick a dorm, like that dorm, because dorms are like divided based on grades and like gender, but I didn't say which type of bias that is. Was that?
Yeah, I'll tell you, the hardest part of tomorrow's quiz is going to be, they're going to say which is the most serious form of bias, or which form of bias is most pronounced. So you're going to have to think through, I mean, because, like, for example, all surveys have some non-response bias. So you're going to have to think carefully about which one is the biggest problem in a particular survey. That's not how it was worded here, I'm just giving you a heads up what to be ready for. So, next, I would like you to take a look at, this is an activity in which we get to practice designing surveys. And just Copy this, take one, hand back, hand one to Mr. Smith back there also, there's an extra one. More visitors than usual today, so a couple of standard deviations from the mean.
But Brittany's gone, so it's almost equal out.
We've never had a negative number of visitors, but thanks for coming, Mr. Smith.
Thank you for having me. Are you gonna
All
do
right.
that problem by yourself?
Yeah, tonight.
All right. So we're gonna try to uncover some truth here. See if it's the true mean or the true proportion. Is there anyone willing to read the opening paragraph? And Andrew, go ahead. Nice and loud so they can hear you on YouTube.
A farmer has just cleared a new field for corn. It is a unique plot of land in that a river runs along one side. The corn looks good in some areas of the field, but not others. The farmer is not sure that harvesting the field is worth the expense. He has decided to harvest 10 plots and use this information to estimate the total yield. Based on this estimate, he will decide whether to harvest the remaining plots.
All right, so thank you. Thank you, Andrew. So a lot like what you have on your homework that's due tomorrow, you're gonna have to select a sampling method. Let's look at some different sampling methods. Suppose that, and would you do me a favor, just draw the farmer's house right over here. Suppose the farmer lives here. This house, and then there's the field, and the corn is there, and then there's a river that runs through it. No, that was the name of the movie. River runs through it. It says a river runs beside it. That's what Andrew told us. Suppose we do a convenience sample. Let's just take the 10 numbers that are closest to the farmer's house. Now, since then the farmer's had second thoughts about this selection, he's decided to come to you and, oh, by the way, he realizes that may not be the same thing. So he comes to you, you're an AP Stats student, you're somewhat knowledgeable, but far cheaper than a professional statistician. So you're being called in, you don't charge very much. And you'll still be allowed to pick 10 plots to harvest early. Your job is to determine which of the following methods is the best one to use and decide if an improvement over the original plan. Okay, so 10 plots that are hopefully representative of the 100 plots is what we're shooting for. He doesn't want a convenience sample. So I'd like you to take out your calculator, and you're going to use a random number feature on your calculator called the random integer, which we had experience with when we were playing the Yahtzee game. And would you do me a favor, and let's label the rows and the columns. So we're going to take our first number, will be either 0, 1, we'll call this row 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So label those. And do you have all the way down to 9?
No.
Or, uh-oh, you know what? It looks like on your paper, the last row wrapped around to the next page. So just draw another row on the bottom. Draw another row of 10 squares to fix that. And then we're going to have the second random number that you pick will be a column number. It'll be either column 0, 1, 2, 3, numbered all the way across, 4, 5, 6, 7, 8, 9. Don't use the dot, dot, dot. So if you wanted to conduct an SRS, a simple random sample, you could do that using random integer. You just need 2 numbers to specify a plot. So on your home screen, which I'm going to hit, I'm going like there, second, wait. That's weird, because it's non-responsive. So, here's what I'm gonna do.
Bias.
Non-response bias. Yeah. It's pretty funny. So, what I'd like you to do is pull up, since you've done this before, go to math, probability, and then is it item 5 that's random integer?
Yeah.
So go to random integer and type in 0, 9, 1. you need one random integer chosen from 0 to 9. That will tell you which row you're picking, and then press enter again, and you'll get a second number. And if mine comes up here, I'll be able to demonstrate this. So, in fact, when you did this, Tony, do you have your calculator? Who does not have a calculator? Everyone needs a calculator for this. Look, if you don't, approach me now with the phone. I'm gonna let you use the loader. Let's do this quickly. Come on, phone for calculator. Let's go. Let's do this. Go to med probability random integer. So when you type this in, okay, let's go to Justin. Justin, what's the first number that came up randomly?
7.
7. And the second number?
Oh, wait.
Just press enter again.
Okay, 0.
0. Okay, so what you're going to do is you're going to put an X in row 7, column 0, like that. Now, the rest of the people are going to probably have 2 other numbers, a different row and a different column. Would all of you please select 10 plots of corn, put an X in the plots that you selected. Press enter twice.
What if you get 2 of the same?
Then, well, like 5 and 5, and that'd be row 5, column 5.
No. Like 5, 5, and then
Then,
later 5,
okay,
5.
so the question is, what do you do with repeats? You just ignore repeats and just toss it out, go again.
That doesn't work.
That's because you're not.
Massive probabilities.
Yeah, well. Raise your hand if you, need help getting started on the process of selecting 10. This is an SRS 10 randomly selected. All right, now, so each group member will conduct, so yeah, you're each doing your own randomization. You've selected 10 plots at random. Raise your hand if you need more time to place your 10 X's in the cornfield. Okay, so that went pretty well. I'm proud of you. Now let's look at another way to sample. Let's go at a stratified sample. So far we've done convenience sample, simple random sample. Now let's do a stratified sample. Please consider the field is grouped in vertical columns called strata. So we'll go column 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Please number the 10 columns 0 through 9. Using a random number table, randomly choose 1 point from each plot, randomly choose 1 plot from each vertical column. So here's how this is going to go. And if you think about what's going to happen here compared to this, can someone think of a disadvantage of an SRS? The one that you did on the bottom of page 1. What might a disadvantage of the simple random sample be? Lewis?
Well, in real life, it's not really convenient because you're walking all the way.
Okay, well, if it's not convenient, that's not what we call a disadvantage. It's like we're happy to sacrifice convenience to do a good job with statistics. We're happy to do that. So that's not really a problem. Moose, can you tell me?
Some area may not cover by the survey.
Yeah, I mean, it's possible. It's possible that the 10 plots you choose are right up in here, far away from the river. What might be different in terms of corn production near the river as opposed to far away from the river?
There's more water.
There's more water over by the river. The corn might grow better, or maybe it'll be too much water worse. The point is, an SRS could work out wonderfully. However, you may not get good representation. This looks like, we'll label these also 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Noah, would you please press enter twice? Or actually, just press enter once on your calculator. Tell me what number popped up.
1 second.
I got
7.
7. So that means for the first stratum, you're going to mark 7. I don't know what number's going to come up on your calculator, but for the first stratum, the first column, put an X where the number comes up, then move over to the next column. Move from the house over to the river. Pick randomly, using your random number generator, pick 1 column from each stratum. And go ahead and move across. So we're on page 2. Yes, so flip over to page 2. And so instead of pressing enter in pairs, instead of having to press enter twice in order to locate a plot, This time you need press enter only once in order to locate a plot. So you've gone through, next time you press enter, it might be 2 again, but the point is you're gonna have 1x in every column selected randomly. Any questions on how to produce your stratified sample, which is done vertically? Now, we can also do a stratified sample again, except this time, instead of picking one corn plot from each column, we can pick one plot from each horizontally laid out row. So this time, we're gonna label them the same again, 1, 0 through 9, and 0 through 9. Okay, but this time, and you'll have to press enter only 10 more times in order to get, in fact, let's do it again. Noah, when you press enter, what's the first you got?
I had 4 in the first.
Okay, so that means on the top row, you put an X in the 4 column, and then move down to the next row, pick 1 X for every row, and that'll be your sample for that one. So, question? Or?
Yeah. 70% of the numbers are 4.
See, it's each sample, I mean, yours has some weird characteristics, but every sample is equally likely to be chosen. Well, actually, well, this is not a simple random sample, but yeah, I mean, it could be that all of them, it's possible that all of them would be nice, so it could be all of them would by the river.
If that happens, should we reach the win?
No.
I don't know if it's actually.
Did you hear that question, class? Andrew said, if you get something weird, like, like most of them are column 4, except for one of them over here, should you redo it? No. Just take what's given according, pick a sampling strategy and commit to it. Okay, let's go to the next page. Okay, so crop is ready, below zero. Okay, here's what actually happened. This is the true yield. So it's a God's eye perspective on what happened. If we knew this beforehand, we could have just added up the 100 numbers. And by the way, I'm not going to tell you what those numbers add up to, because that would be like the truth. We're trying to approximate the truth using our sampling method. So what I'd like you to do is you're in groups of 3 or 4, and let's ditch the communion sample. In each group, 3 here, 3, looks like we have one group of 4, the rest are groups of 3. So if you're in a group of 3, one person take the X's from your simple random sample and actually add up the 10 numbers that correspond to those 10 X's. And then in your group of 3, another person is going to be assigned to add up the 10 numbers in the vertical strata, and then the third person in the horizontal strata. If you're in the group of 4, then your 4th person is going to add up the numbers from the convenience sample, which is these right here. And what you're going to do is find the mean yield per plot. Or in other words, add up the 10 numbers that correspond to your 10 X's, and then divide that total by 10, and put your answer here. Now, then what you're going to do is multiply this number by 100 to fill in the next column, because there's 100 plots. So go ahead and divide and conquer in your groups. One does the SRS, one does vertical, one does horizontal.
Wait, so we are doing it based on
your sample of X's that's on your paper.
I can do the simple right now. Or you, I don't care. So I can do it.
Yeah, actually, we've got time. I changed my mind. I would like you,
I'm doing horizontal strata.
class, I'd like all of you to do all 3 of these. I'd like all of you to add up your 10 numbers for your SRS, add them up, divide by 10 to get this number. So each individual person should have 3 numbers filled in. I don't care about the convenience sample. We know that one's lame. So take your SRS, find the 10 numbers that correspond, add them up, divide by 10. So we will do a group aspect of this, but for now, just all of you fill in these numbers. Now, if you have those three numbers, I'd like you to come and report them here on the signboard by standing up, walking over here, and writing your triplet of numbers in these three boxes. Add them up, divide by 10, and then multiply by 100. And decimals are okay. We like decimals when we're calculating means or averages.